Hello and welcome to Food Safety Fridays. My name's Simon Timperley from the International Food Safety and Quality Network, and joining us today is our very good friend from Safefood 360, George Howlett. Good afternoon, George. How are you doing?
Afternoon, Simon. How are you?
Super. It's weekend nearly, so I'm always good.
Yeah, that's always the good thing about IFSK webinars. It's always on a Friday afternoon,
Exactly.
which is great.
Best day of the week. So we're on wind down, but before we do that, obviously we've got our very important topic, and we're going to be talking about validation of cleaning and sanitation programs. So I'm going to play the sponsors ads, of which Safefood 360 are a kind sponsor. And while I do that, as you were already doing, type in and tell us where you're joining us from today, because it's always lovely to see. Okay, we'll be back in a couple of minutes.
The world of food has changed a lot in the last 100 years. But one thing that doesn't change? Ensuring the quality and safe handling of food. No matter what changes are yet to come, we're proud to always be on our clients' side, shaping the future of food, today and tomorrow. AIB International, ever onward.
Okay, we're back. Thanks to our kind sponsors. I don't know if you've been watching the sidebar or where everybody's joining from. There's a lot of people from the Philippines I noticed today. Maybe a couple of coaches in from the Philippines. So you're all very welcome. So I'll be back for the Q&A later. And for now, hand you over to George for the presentation.
Okay, thanks, Simon. Okay. I just need to figure out how to. Oh, there we go. Okay, so hi everybody, and welcome to this IFSQN webinar on validation of cleaning and sanitation programs. Just few quick comments before we get started on it. So while the focus of this particular session is sanitation and cleaning and the validation of those programs, a lot of what we're going to cover today does apply equally to any other food safety control measure or control point. So that could also be CCPs or operational prerequisite programs as well. The reason we're selecting cleaning and sanitation, because I think it's quite an easy one to relate to, and there's quite, burdensome demands around that and some standards. But just bear in mind that the technique and the tool that we're presenting here can be used for other control measures. So there's a lot more value in today's presentation that goes beyond cleaning. So just keep that in mind, and you might find it useful in the future. Just before we get started, if you would like to use some of our free resources on Safefood 360, please feel free to log on to that website address there. You'll find lots of good quality white papers, tools, ebooks, and other resources that can help the practitioner out day to day in their work and in their job. So you're more than welcome to click on there, have a look around, and you might find something that's of interest to you. Okay, today's session, validation of cleaning programs. So just a few brief words about myself. I'm Director of Digital Innovation at Safefood 360. Background is as a food scientist, food technologist, worked in various capacities over the years, including consultant, lab technician, manager. So I also do lecturing at the Technological University here in Dublin on the master's program of food safety. So it's obviously a subject quite close to my heart. Okay, so just by way of introduction, let's kick off with some GFSI requirements and specifically BRCGS. So why are we concerned in the first place about validating cleaning programs? You may ask that question, and the probably simplest answer is because very often standards and customers require you to do it. So, for example, in the BRCGS standards, we can see here, it's quite a clear statement. And I think it's worth reading out, though, because it sets the scene for what we're about to discuss and what we're going to talk about. So that standard in particular says that where cleaning procedures are part of a defined prerequisite plan to control specific risks and hazards in your food business, then the cleaning procedures and their frequencies should be validated, and you should keep records of that validation. So what's that saying in brief is that if you have a cleaning process or procedure in place which has a very specific purpose, in other words, to eliminate or reduce a hazard that you have a particular concern about, then that cleaning procedure should be validated in some way, shape, or form. We're going to talk about what that means, validation, in a moment. And interestingly, it also says that you have to keep records of that validation. Before we get stuck into that whole area of validation, we might just talk about cleaning for a moment. So what is cleaning? Well, at a very high level, cleaning is a process. It's a process that requires different types of inputs, mostly energy in one form or the other. And that energy can be in the form of heat or thermal energy. Could be in the form of mechanical energy, so that could be actually physical action. That can be human, and it can be machine. And also then the use of chemicals or chemical energy is put in some way, shape, or form. And then the other component that's required is, in fact, time. And I mean, if you're a physicist, you will probably argue that time in itself is also related very close to energy in some way, shape, or form. Okay, so that's what cleaning is in general. The main point there is that cleaning is around trying to remove or eliminate a hazard or a substrate in some form by the application of those different types of energies, perhaps in different proportions, depending on what it is that you're trying to achieve. These cleaning procedures can very often be targeting multiple hazards, so it's very seldom it should be just tackling one particular target issue, and they can be in any form: biological, chemical, physical, or very often is the case these days now, where allergens are of concern as well. One of the other areas, of course, where we need to be conscious is the whole area of the chemicals themselves that are used and residual levels of those that may remain after the cleaning procedure, and they themselves can be chemical hazards in their own right. What are hazards? So I'm not going to dwell on this, guys. We all know what they are. They're biological, physical, or chemical agents which, if present, potentially can cause harm or some sort of adverse impact, or impacts in terms of business as well. Depends how you want to define the scope of these hazards. So what exactly is cleaning validation? Well, one of the best ways to explain validation is probably in the context of this other term, which is widely used in the industry, called verification. So let's talk about both of these just for a moment, and we will linger a little bit on these just to make sure that everybody's clear on the difference, and then that tends to facilitate a clear understanding of what validation is. The reason we do this is because very often these terms are used and interchanged and used to describe the same thing. And so it creates a bit of confusion, I think, from time to time with people. What is the difference between verification and what is the difference between validation? And indeed, in many standards, they're often used in a confusing way. And for example, under FSMA and the FDA, FSMA requirements, verification is kind of also used to imply validation as well. So it can get quite confusing. So let's try and clear up our understanding a little bit. So what's verification? Well, in a very high level, verification is proof in the context of cleaning. It's proof that the cleaning has been conducted according to the approved procedure. Okay, so most food companies have a documented procedure for doing cleaning activities. It usually spells out quite a bit of detail around that. And verification is simply the act of checking that the cleaning has been done against that procedure. And it's not interested in answering any other question beyond that. Have we done what we said we were going to do? Simple enough question, and usually quite simple enough answer. Verification is usually conducted through visual inspection, perhaps, or through some sort of audit, or it could be through some sort of test. Okay, so that's verification. Checking what it is, that just simply checking, have we done what we said we would do, or what has been documented? Now, validation, on the other hand, asks a different question. So it asks a question which is kind of beyond the mere check that you've done something the way you should have. So it kind of asks the question, is what we say we were doing, is that in fact good enough to achieve the objective? And the objective in this case is safe food production, if we'd like to put it that way. So verification asks the question, the first one is, have we done what we said we were going to do? And then validation goes beyond that and says, well, what we're actually doing, is it actually good enough to achieve the objective? Because very often it may not be. So for example, if you order a car and you have a requirement that it can reach a top speed of 100 kilometers per hour, for example, and you take it out on the road and you put the foot down and get it up to 100 kilometers an hour, you've checked that it can in fact do that. However, you may want to take up a career as a bank robber and need a quick getaway, and you probably need to ask the question, well, hang on, is 100 kilometers an hour top speed in this car actually good enough for the purposes I need? Which in this case would be a quick getaway. So I know it's a crude analogy, guys, but I just wanted to kind of maybe explain it to you. So let's recap. Verification is simply checking that we have done what we said we would set out to do. Well, validation is asking that second question, is what we said we're going to do good enough to achieve safe food production? Okay, so hopefully that's tidied that up a little bit in terms of our understanding. Now, validation itself, you can find various definitions around this. Codex, for example, have one definition, and we might just have a quick read over that. So according to Codex, validation is obtaining evidence that a control measure or a combination of measures, if properly implemented, is capable of controlling the hazard to the specified outcome. So that's pretty much a fancy way of saying what we just said there a moment ago. But there is one interesting addition, and that's the first couple of words there, obtaining evidence. So it's sort of implying that validation has some sort of requirement or demand to do some sort of inspection or testing or data collection, or putting in place some evidence so you can actually say something is in fact validated. Now, food businesses in general, by law, as you know, need to clean their operations. You need to have a clean and tidy factory by law, and then obviously if you're complying with other standards, GFSI or customer requirements, you'll absolutely require it in that case too. And what that really is saying is that there's a legal obligation on a food company to do things in terms of cleaning and sanitation that correctly controls the targets hazards that may exist. Okay. Now, food businesses usually, when they put together their cleaning programs, they do so on the basis of a risk assessment, you would expect. And when they're happy that the cleaning procedures are identified and they know what to do, they'll document those in some sort of standard operating procedure. So that's just writing down exactly what it is that needs to be done. Okay. So that's just covering off those general, that general kind of definitions there. Okay, so when do we need to do cleaning validation? Well, you need to do it under a number of circumstances, usually because you have to do it. So the law says so, or a standard like the GFSI might say you have to do it, like the BRC, for example, we've just seen there. You may also want to do it when a risk assessment tells you you should do a validation. And what that means is that the risk assessment has indicated in some way that this cleaning procedure compared to others is more critical. Now, examples of where that could happen is if you're producing food products, a range of food products. Some may have some allergens in it. Other products on the line may not have allergens, and you need to do a good clean down between the batches. In that case, that cleaning down procedure probably needs to be validated to make sure you don't get cross-contamination for allergens. Could be also, cross-contamination between species that you might be producing on the line. So they're just some examples. Or another example could be that the machinery or the items are maybe particularly difficult to clean in areas, and they need, run the risk of hazards accumulating and inoculating the product in some way and causing problems. Okay. There are procedures which, by definition, don't need validation, so they will be kind of quite low risk. So it's probably not sensible to go, undertake a validation of cleaning programs, say in warehouses with enclosed, food packaging, for example. So you're just not going to get a whole lot of bang for your buck there. And validation as an effort, as an input, an activity, can consume a little bit of time. So you want to use that time productively. And that's where the risk assessment comes into play. Risk assessment is crucial to stop you wasting time, effort, and resources. Okay, so before you undertake a kind of a validation of a cleaning procedure, there's probably a few things that you need to do in advance, just some prep work, not dissimilar to what you might do in HACCP, in fact. And you may already have done a lot of this work as part of your HACCP study, particularly if you're following Codex principles and steps. Okay, so some of those, just to set the scene for you, validation at a very basic level is an experiment of some description. So for those of you, and most of you involved in this industry will be, qualified or trained scientists, maybe in food science or other disciplines. A validation is essentially an experiment that you conduct, and like all experiments, you're trying to either prove or disprove a particular hypothesis, which is of interest. And so in this case, the hypothesis is, is this cleaning procedure is in fact capable of addressing the hazards and achieving safe food production. And I think it was Richard Feynman who once said about hypothesis is that, I think he said something along the lines of, no matter how elegant your hypothesis may be, or how smart you happen to be, or how eminent your title might be, if the experimental data doesn't back up your hypothesis, it's wrong. So I think that's a quite an insightful comment to make, because how many food companies around the world have lots of cleaning procedures in place designed to address hazards, spend quite a bit of money on these cleaning processes in terms of chemicals, labor inputs, energy, and haven't really proven in an experimental or scientific fashion that they are in fact capable of doing it. How many food companies never really get the answer to that question until there's some sort of issue in the marketplace, for example, which is costly or potentially quite costly. Okay, so in this case, we're trying to prove that the cleaning procedure is capable of achieving the objectives, that is, production of safe food product consistently. And just bear in mind that the procedure we're going to go through now on doing validation is probably a good idea that you define and document that in advance. Like all good experimentation, you should have a methodology set out, which you can follow, which allows for you to reproduce your results if that's something you wish to do. Okay, so what is this cleaning validation procedure we're going to look at? Okay, well, cleaning SOPs for cleaning processes are in place. So you're going to check that. Do we have in fact, SOPs for the cleaning that's done at the moment? Because if you don't, you probably need to start there, get your cleaning procedures in place. Do we have cleaning schedules? Check that one out as well. Usually you'll have in the program, you will obviously have a schedule for how often cleaning should be done. Other things to consider for the cleaning validation procedure are, what are the contact surfaces that you're interested in? Is there cleaning done after product changeover? Is there cleaning done between batches? Do you need to characterize your products? So you may not need to do every single product validation against individual products. So grouping or categorizing your product range, like in HACCP, can be quite a useful exercise as well. And periodic evaluation or re-evaluation of the validations that you use. So just consider some of these things, and there's more. Okay, so just checking your procedures if they're in place. You might want to do a trawl of those procedures and just see, is the procedure detailed enough? So validation is essentially, as we say, is like an experiment, a scientific exercise, if you like, and you want to measure something. And like all good experiments, you want to have a consistent sort of environment for that. So you want consistent inputs, and you want to make sure that variation is as low as possible. Okay, so double check the cleaning procedures. Do they have objectives and responsibilities defined? Does it state the cleaning chemicals that should be used, the concentration, the makeup procedure for those chemicals? Is there issues such as quality of water, time and temperature, flow rates, pressures, rinsing procedures, cycles, and so on? So any of you guys who are involved in cleaning procedures and CIP will be fully aware that these parameters of cleaning are crucial. And ideally, your procedure should document them. Now, if your procedure doesn't document them, check out whether it should and make those revisions before you attempt to do a validation of it. Okay. Other stuff I could include is a description of the equipment you should use when cleaning. Probably more important for some cleaning tasks than others. But if it's required, document, make, model, etc. Training of operators is critical. You need to ensure that your validation on the cleaning takes place only where trained operators are doing the work. That's absolutely vital. Why? Well, very simple. Reason is that wherever there's a human activity, you're going to get variation. And you want to keep that variation as low as possible in your validation procedure. Okay, if there is kind of a widespread of operator competency when it comes to cleaning, you're going to see that in your results. Okay, and you'll end up having to go back to do it again. So just double check they're being trained and they've been signed off and as being trained and competent, and that's a good place to start. Okay. Consider if you need some equipment. So things such as conductivity meters, pH meters, are they used to check the cleaning processes? Are they calibrated? Are they fit for purpose? Also consider how you're going to do your testing for validation. So what kind of procedures are you going to use? You're going to use direct sampling, rinse samples, swabbing, rapid test methods, etc., etc. So just tie all that down in advance so you know exactly what you're doing. Yep, so analytical methods, yep, whatever methods you're going to use, again, they should be documented so you can have a repeatable testing approach. Acceptance criteria, so what is the measure going to be? What's the target? What's the upper limit or lower limit if that's applicable? Okay, so this is all setting the stage, doing the spade work, and pinning down exactly what it is you're going to validate. Okay, and try and spend a good bit of time on this and make sure it's all documented for reference purposes. Now, I suppose aside from anything else, guys, I mean, depends, how inclined you are towards this type of approach, which is slightly more scientific than the gut reaction. Yeah, that cleaning procedure looks pretty okay to me, should be fine, and I'm too busy anyway to really check it. So that can often be the case, legitimate reasons. But this can be quite an interesting exercise in its own right, not just for cleaning, but for all the critical aspects of your food safety system, because there's a certain reality of food safety in the world, and that is food safety issues in the marketplace and recalls invariably all come from plants which have HACCP plans developed for them. And one of the reasons why these HACCP plans fail is because they're frequently not underpinned by some good sort of validation or scientific approach around the core critical elements, and this will help you pin that down in a structured way. Obviously pay a little bit of attention to the cleaning chemicals themselves. They're crucially important where they're used. So make sure you have the data sheet available. It tells you pretty much everything you need to know about the safe and correct application of that cleaning chemical. Because you may, for example, find yourself that you can't validate this cleaning procedure because you're just not using the chemicals correctly. So you need to know that in advance so you can go back and start doing some root cause analysis if you need to do that. Okay, so that's just some comments there about it. Categorization. So take a look at how you're going to do validation. So because it can take a bit of time, and none of us have all the time in the world, one good way of doing it, similar to HACCP planning, is to take a look at the product range, and you can probably group common products which present typically the same risk profile into one group and select one and assume that that's representative of the rest of them, and that can just help reduce effort and time. Probably a good idea, again, you can focus on the worst case scenario for the products. So maybe take the highest risk products, the ones that are more sensitive and probably need a bit more attention as well. Cleaning validation reports. Okay, so very important. Record keeping is crucial. You will collect records such as the cleaning records themselves, copy of the cleaning chemical data sheet that you used, gather the instructions for doing the sampling and the test methods, and just collect all them into a nice little file on the PC with your final validation report, which I'll show you in a moment. Okay. Equipment, yep, you might want to collect some documentation. Again, the HACCP system, if it's well done and it's robust, will already have a lot of this filed as one of the pre-steps to HACCP. So you just want to double check that the machine surfaces, they're fabricated from suitable materials, that they're fit for purpose. You may have done a bit of an assessment of them to see, are they difficult to clean in some areas? So gather that information, read up, and get to fully understand what it is that you're trying to validate. Okay. Yeah, some more notes there just on that. Okay. Now, the other key area is the testing. So validation is all about doing something, setting it up in a standard way, and then doing some testing at the end of that to gather information and data about it. So when it comes to cleaning, then what we're talking really about is things such as sampling. So where are we going to test? Are we going to use direct surface swabbing methods, or for CIP systems, you may be using rinse samples, perfectly good, or are you going to use a combination of both, for example? So you should also look at resampling methodology. So if you get some results which look a bit odd or strange, you may want to just do some resampling to make sure you're just not picking up just an outlier result in that case. So direct surface sampling is normally the method used. Different types, different ways of doing it. So, but again, you need to figure out and define what that method is going to be, what swabs you're going to use. Are they suitable for what you're doing? Is there some sort of considerations around the reagents that you're using? So I'll just again drill down into that and make sure that the person who's doing the sampling is in fact trained and can reproduce the methodology, so you're getting good consistent data collection. Okay, so consider all of that, because again, you want to avoid introducing variation as much as possible. Okay, so other things to consider for direct surface sampling is the location from which the sample will be taken. So you might want to actually identify the sample points, the swab area, and repeat that as well. So rinse samples are an indirect methods normally used in CIP systems. So you may want to be just collecting and sampling the final rinse waters to go through the system, and various other methodology. Okay. Other analytical methods. Great thing about these days is the rate at which these methods are progressing is impressive. The rapid nature of testing really helps this sort of work out. So other things you can consider, such as ELISA tests, specific allergen testing, non-specific testing, so the ATP type test kits as well. Consider the limit of detection, really important. You need to just take a look at that and see, are the test methods sensitive enough for you to really do a proper capability assessment of the cleaning method itself, efficacy, reproducibility of the methods as well. So a little bit of reading there, a little bit of checking out before you're happy enough. Okay, establish your limits. So what's the target limit? What's the upper limits that you're going to use to measure capability in the validation of the cleaning programs? So the nice thing about this is that limits allow you to plot your data and trend it and do other slightly more sophisticated measurements around that. Okay. So in establishing the critical limits, the approach which you can take is try to be as kind of product or line specific as you can. Do the grouping exercise and choose the worst case scenario as your targets, which can can give you some comfort around the capability of the cleaning procedures. Limits can be expressed in a variety of different ways, depending on the focus of the validation. So you can express it in terms of concentration, limits per surface area, for example, CFUs per cm squared, in the rinse water as parts per million, or indeed it sometimes can be a visual assessment as well. Just depends on the requirement. But in all cases, you need to be able to collect enough information that allows you to plot and measure the distribution of the results. So visual is quite limiting that way, but there are statistical tools that can be used to account for attribute data like that. Some of your critical limits will be kind of pretty much acceptable or not acceptable. So, the presence of an allergen probably just will be a no-go. And in that case, you're operating down to the detection limits of the particular test. For that reason, again, for validation, you need to ask the question, is the detection limits of the method I'm using sufficient for me to produce safe quality food? Okay, so again, that's something just to keep in mind. Okay, so there's no absolute correct way to do a validation. What I'm just suggesting here is one way of doing it. You may have other approaches to it, or you may want to vary or deviate around what I'm showing you. Perfectly fine, as long as you are happy that the experiment essentially is well designed, can reproduce the results, and gives you a certain degree of confidence about your decision making. Okay, so what today is just about a good example that you could perhaps use. Okay, so we're going to conduct the validation now. We've done a lot of prep work, quite a lot of prep work, guys. I do accept that, and you may not need to do all of it. And a lot of it may already be done in the HACCP study, and that's a key point. So don't reinvent the wheel. Go back to your HACCP documentation. You may well just find that data already there and reviewed and assessed. So let's look at the procedure. Well, you have your pre-validation tasks. We've already gone through those. So just go through them. I've itemized them there just to help you out. Okay, collect your data. Okay, so collect data on the hazards and risks that you should be concerned with. Again, refer to HACCP. Look at the legislation, because maybe there's something there that mandates you to do something in a certain way. Get your data on your chemicals and your data on the analytical methods and file them. Make sure they're all there in your validation pack, whether that's real on your desk or whether it's virtual on your PC. It doesn't matter as long as you have everything. Define your parameters and your decision criteria. Okay, so that's important. What are we looking at? What's the parameters of what we're doing, and have we got everything correctly documented? Okay. So next, we're going to do the validation activity. So let's just look at a scenario. We have a production line, let's say producing a product. Let's say we're concerned about a pathogen or an allergen. Okay, so we're going to do a validation on this line to check that the cleaning procedures that are used, let's say between a changeover, are capable of producing safe food products. Okay, so what we're going to do is we're going to start with this cleaning procedures. Okay, it's documented cleaning procedures. And probably what you're going to do first is double check that the cleaning is being conducted according to the procedure. Now, that's kind of a physical exercise, guys, literally going down onto the production line and observing the relevant cleaning activity for that procedure, just to double check that A, they're doing it according to the procedure, first of all. And if they are, then you're good to go. But if you find in that particular check that the cleaning is not being conducted according to the procedure, then you need to answer a question. A, is the cleaning not being done according to the procedure, or is the procedure incorrect? So you have a bit of work to do there just to make sure that you have that right. Okay, so hopefully everybody understands that. It's important that you just double check the procedure reflects what has in fact been done on the line in reality. If not, then you need to have a bit of a discussion around that to see what the issue is. Okay, once you've been able to tick that off, then you're good to go on to the next step, which is analyzing your results. So after the cleaning is conducted, you're going to do your testing. Okay, so that could be your swabs, it could be your rinse swabs, it could be some rapid testing kit that you're using. So whatever it is going to throw up some data. And then you're going to collect that data and record it. Now, you need to consider how many cleaning cycles you need to go through, okay, to get a representative sample size. And that can be anything from whatever, from 10 to 100. I won't even suggest what the number should be, but just bear in mind, it should be enough for you to do some statistical analysis on the cleaning activity itself. Okay. Now, very often the best way to do that is to conduct what is known as a capability study. It's not a terribly difficult thing to do. In fact, it's quite straightforward, but can be very powerful in stepping up your validation from an expression of opinion in some cases up to some good, solid statistical scientific analysis of the data coming off. We go back to Richard Feynman's comments. Doesn't matter how smart or clever you are, or how elegant you think your cleaning process is. If you don't have clear data, objective data to back it up, then that's all you have is simply an opinion, I would suggest. Okay, so you're going to collect that data, you're going to plot it into a model I'm going to show you in a moment, and then you can have two possible outcomes. One is the process is capable of meeting the limits consistently and repeatedly, and therefore is validated, or it's not capable and therefore not validated. Okay, so it's quite simple and binary in its approach, guys, but we back it up with a little bit of analysis of that data. Okay, so let me just spend a little bit of time to explain this slide. Normally this slide just builds up, but on this platform we just can't do that, so it's all up there in one go. But let me take you through it. The top of your slide here has your target value, so we're going to target 100 or use in this case. Okay, so we're using a rapid test method. We have an upper specification limit of 200 RLU and a 0 limit, obviously, which is desirable. So we're just going to set it at 100 and have an upper and a lower limit of 0. Obviously, 0 is probably going to be your target. For statistical reasons, it's better to have an upper and lower limit on this one. Right, okay, so we do our cleaning, then we do our swabbing or testing, whatever it is, and we collect our piece of data, or it could be sample size data, it could be average, means, doesn't matter. Pop your data into your record here. So the first reading, we got 80 RLU, that's great, and then we plot that on our distribution curve here. We have another test of 40, we pop it in there, 160, pop it in, 100, and so on. And as we continue doing that, we're going to build up a nice distribution curve, we hope. So this is why it's important, guys, to do sufficient sampling. Obviously, the more samples you have, the better. And then beyond a certain point, it just doesn't add much to your analysis. But you just need a sufficient amount of data. Now, there are all sorts of fancy tables and sampling plans and national standards for figuring all this out. You can certainly get into that if you wish, but I would just say just collect sufficient sample data so you start getting some sort of curve out there. That should be a good place to start. Okay, so as you plot your individual data items coming off your cleaning cycles, you can plot them out. You'll get a curve developing here like this. And we can see here already that the lower spec limit and the upper spec limit, we have a few data points lying outside of that, and that's going to suggest to us that this cleaning procedure is probably not sufficiently capable of meeting the objectives. Okay, so you can see that there. Now there are some calculations that can be done and that will tell you exactly how capable or not this process is. But hopefully you could just see that there. It's a very simple process. Capture your data, record it, plot it on the graph, and then you'll build up a distribution. In this case, it's a pretty normal distribution, but it seems to have a kind of wide spread or range of figures, which is telling us it's probably a little bit kind of too much variation in this cleaning method. Okay, so now, okay, yeah, so I'm just overlaying here just a normal distribution curve, which we pretty much have in this particular case. Yeah. Okay, you can see here upper spec limits in this example, creeping out a little bit beyond, but it might well be sufficiently capable for the purposes. So these distribution curves, they have many different names. We just call it the normal distribution curve for the moment. So in this particular example here, I'm just showing you an Excel workbook version of that tool. Okay, so guys, if you go on to Safefood 360 resources, have a little bit of a poke around, you're going to find a tool for doing exactly this. Now you can use this not just for cleaning, but you might have a CCP or an operational prerequisite program in your plans, and you might say, well, we're definitely going to do the CCP's capability study on those. And we might take some of the more important operational prerequisites and do some validation on them as well. Okay, so you can use this tool for all of that. You can see the tool here is very straightforward. You're just going to pop in some information about the study. You're going to plot in your plug in your limits up here, and then all your data points, you can pop all them in. This tool will automatically plot them for you and produce a distribution curve. It's just on its side here in this case, guys. But you can see here, even with a limited number of samples, you can already start to see, the bones of a distribution curve being developed out. And the software will just do the statistical analysis. You don't need to worry about the formula, and it will tell you and show you in red whether or not the process is capable. So it measures a few things like standard deviation, CP index, CPK. Okay, so these are all kind of nice standard methods for measuring process capability. Really simple tool to use, guys. If you can use Excel, you can use this. Okay, so that's there in resources. Do download it, have a look around, and have a go at it. Just pick one CCP, see how it works out for you, and or one cleaning method. And if you like it and it feels good, then you can over time do the validations on other things as well. And I'm sure your auditors and customers coming in to have a look around will be quite impressed with the fact that you've done this. And I'm going to explain why it's important, guys, because the management of food safety is by definition a scientific discipline. And like all science, the maths and the statistics is a way of actually testing a hypothesis without actually even having to do it. So if you collect enough information here, you can, you don't necessarily need to start predicting the future around each cleaning program. So the statistics allow you to kind of run some quite kind of modeling and tests around what's happening without having to watch every single activity that ever happens. Okay. And the other interesting point about this approach is if you just are sampling every so often, getting pieces of data, the chances of you actually getting the data between the limits is much higher than you capturing the one outside. So you may be under the impression that you're actually in control of processes and cleaning, when in reality you're not. It's just a question of time before these outlying points here crop up, and then you have problems. Okay, so very useful and easy to do. Okay, so after you've done all of that wonderful stuff and produced nice fancy charts and you've impressed everybody with what you've done, you're gonna make sure you've documented everything. Do, like all good experiments, document everything you do so you can be challenged, and also because you can reproduce the experiment at a later stage and cross-check your data if you like. Now, finally, what you need to do is draw a conclusion, and with the model, the capability model, your conclusion is going to be pretty much at two levels. The first level is this process capable, or this cleaning procedure capable, of meeting the criteria and the objectives? The objective being safe food production at the highest level. Okay, so the answer to that question will be either yes or no. It's capable, it's not capable. It's validated or it's not validated. Okay, so that's the first thing. Now, depending on what the outcome of that is, then you might decide to you may be required to take a look at what's happening. So let's say the process is not that capable, then you need to maybe do a bit more investigation and make some recommendations. So for example, let me just go back, and I'm just going to, apologies for this now. Okay, so let's say we get a nice normal distribution curve like this here, okay? Then we can say, well, okay, the process is quite stable, it's consistent, has a normal spread of normal distribution of data. We can also see that it's quite, it's tight enough, it's sort of sitting in within the limits here, which is great. And we could be reasonably satisfied with that process, that cleaning process. Now, if this curve started way out here and peaked in the middle somewhere and finished outside here, we would say that we do have a normal distribution, but the variability is too high. There's too much going on there, and we need to take some action to bring that curve in a bit and make it a bit tighter and a bit more stable in regard to these specification limits. So you may go back and ask them questions. Okay, well, listen, what potentially could be going wrong here? Could we be using the wrong cleaning chemical to start with, or are we just simply not using the correct one in the correct manner? Is it possible that we need more training for staff? Maybe that's another reason. Is it possible that the equipment and the materials that we're using are just not fit for purpose, etc., etc.? So you can start going down that list of possible factors that may be creating too much variation and variability in your process. Now, you might also end up with things called bimodal distribution. So I could have a kind of a curve peaking here and then a second one over here. And that's telling me that there's some very strong bias going on in the system. Maybe there's one cleaning operator in particular, for example, who isn't sufficiently trained and is just causing that skewing and that, that second kind of average peak in the process. So again, that is a great example of how you have a lot more insight into what's going on in the process or the cleaning activity, something you wouldn't get just by scanning, individual swab results at the verification stage of cleaning at the end of it. Okay, so just to get back here. Okay, so your conclusion is that, yep, we're pretty good. We're in there. It's a capable cleaning procedure, or it's not. We're going to do some more analysis, maybe some root cause analysis, and try and figure out what we need to do. Now, key point is when you do make a change in an attempt to bring the cleaning procedure back into kind of a more acceptable level of variation, ideally only change one thing at a time. So don't go changing multiple things, because you can run the process again if you change one thing, and you can measure the direct impact of that one change. So for example, we're going to change the cleaning chemical. Do that and then repeat the validation process. And that will tell you whether or not that was a factor. If it is, that's great, you've solved the problem. If it's not, then you can move on to the next thing. Okay, well, maybe we need to do some more training and have a go, do your validation again. And aside from everything else, it is possibly quite an interesting exercise, if nothing else. And the amount of insight you gain into your operation is significant too. Okay, so if you need more information on that, guys, two links here for you. One is to the Excel tool I just showed you in the presentation. And then we have a nice white paper which goes into everything I've just discussed today in a lot more detail with a step-by-step guide on how to do this exercise. So I think that's it for me. Yeah, just to say thanks to everybody for listening. I hope you found that session of value, and certainly would hope everybody will have a go at this type of validating exercise, and certainly love to hear how you get on with it as well on the IFSQN forum. We can have a chat about it later on. Okay, that's it from me. Simon? Yeah.
Super. Yeah, thanks very much, George. That was great. Lots of comments in the sidebar. Just to say to everybody, you'll get a copy of those slides afterwards. We'll follow up with an email with the recording the slides as well. And in there are links to Safefood 360 resources where you can download those white papers, tools, etc. That I'm sure you'll find really helpful. There's been lots of questions all the way through, George.
No problem.
And there's a lot of people online, 600. So we'll try and pick up some questions if you've got 10 minutes now, George.
Yep.
Okay,
yep.
yeah.
Of course, yeah.
Okay, so Clifford, how do you validate cleaning frequency?
Pretty much in the same way. So if you have a cleaning procedure, it's set at a particular frequency. You do a validation at that frequency, okay? And the analysis will tell you whether or not the process is capable. And you might recall at the end of the slide deck, I said there, look, if it's not capable, you have to go back and start looking at certain things. So one of those things you could look at is the frequency of cleaning. So you make that change, make it slightly more frequent or less frequent. If your curve is very tight, if you have a super capable process, you might decide to make it less frequent. So that's how you do it. You do your validation, look at your distribution, see is it capable or not, and then change the frequency and repeat the exercise.
Okay. lots of praise, really. So, Manta, what is a typical quantity of validation should be done to be considered as validated?
Oh, I suppose we're talking here about sample size. Yeah.
Yeah. Yes, I think so.
Yeah. So it's like all experimental exercises. You need to have sufficient data points or data set to make your decisions and your conclusions. Look, it's a difficult one to answer because it depends very much on the concrete situation on the ground. And as I said, the BSI have produced lots of wonderful, guidelines and standards around this. So what I would say is it really much depends. You kind of know at a very, very basic level and a very layman's level, you're getting there when your curve starts to, normalize out and you get good distribution. At that point, you may decide that you have sufficient data sets. That'll be a learning process in its own right, I would say. So you'll know in the future after doing a few of these validations what a good sample size is. Yeah.
Okay.
So, yeah.
Another sort of statistics-based one. For capability study, is statistical process control a good tool? What is the recommended CP and CPK to evaluate if the process is capable?
Yep. So the capability study tool is actually, will be a standards component of the SPC toolkit. And there are specific indicators around CP, CPK. So in the workbook, which you're going to download, there's a bit of narrative there, and the white paper explains all in detail what you should be looking for. Now, in the workbook, we've already built that in. Okay, so you don't need to worry too much about it. You'll see it come up in red if it's outside of what you desire to see. Standard deviation is another method. Usually you want to keep it, plus or minus 3 standard deviations from the mean as your operational control limits, but that's on a whole other day's discussion. We might actually do a session on that on SPC, just to drill down. Maybe that's something else we can do. Yeah,
definitely, that'd be a good idea.
Yeah. Okay.
Does microbiological testing validate a cleaning procedure?
It can, of course. Yeah, definitely. So you have a hypothesis. Your hypothesis is that this cleaning procedure is capable of producing safe food products. That depends on, obviously, the presence or otherwise of hazards. And those hazards could be pathogenic bacteria, and microbiological testing, of course, is the way you would determine that. So yes, of course.
Okay. Have you, by any chance, come across validation programs that take into account biofilms?
Not personally, but the methods that I've shown can be used for anything where a piece of data is collected. Yeah. Okay. So in that case, the validation of the cleaning would be to the hypothesis: is this capable of preventing the formation of biofilms? So you need to construct then your validation experiment around that hypothesis and determine how you can detect, measure that, and analyze it. Yeah.
Okay. Eric, what would you do when the entire cleaning program cannot really be fully followed, busy production hours, etc.?
Well, I'd probably go to the nearest magic wand shop and purchase one and wave it around profusely in the hope that you could get something out of it. That's an operational issue. It's I mean, you can still do a capability study on that, but you're pretty certain that you're going to get a process which is not capable with a very wide spread of variation. And at least you can demonstrate and prove that maybe to the management. It could be a good tool to argue for improvements and changes.
Yeah. Okay. Arinola, if validation for microbial inactivation was conducted and at the end the results showed the cleaning procedure is not capable, not validated, can we still call the study a validation study?
Can you just repeat that question again?
So basically the validation study failed. Can we still call it a validation study?
Yeah, absolutely. Yeah, because you've disproved the hypothesis. Yeah.
Okay, Belicia, what are the pathogens to consider to check for the effectiveness of cleaning and disinfection of a food contact surface, e.g. swabbing of interior surface blade of a blender?
Yeah, I mean, so there's no hard and fast rules around this. So again, in the pre-validation phase, you need to sit down and decide how you're going to do things. And a lot of that depends on, again, the concrete situation on the ground. So, you may decide, listen, I'm going to do some generic swabbing for total count, for example. That could be one way of doing it. I'm going to use a rapid test kit to measure for the presence of protein. I'm going to use a specific test kit for the measurement of a specific allergen, and so on and so on and so on. It really depends how you want to approach it. You need to consider costs, time, so in initial validations, you could just decide to keep the costs low and go for total generic sort of counts as a starting point. But it really depends. A lot of this depends on the experiment design and what you need to achieve. Yeah.
Okay. Let's have a look. It's a bit of a broad one, this. And can you please give the reasons, repeat the reasons for a HACCP plan failure?
Oh, well, I mean, it can fail for any reason, but usually the reason most HACCP plans fail, I would suggest, is because of poor hazard identification. The HACCP plan simply hasn't identified the target, hazards, the ones that really should have been considered. So that's usually the reason. Yeah.
Okay. Tiffany, any guidance for the validation of disinfectant fogging to improve air quality?
Yeah, again, so if you're doing fogging, you should be fogging to achieve a certain criteria or specification. Figure out what that is, and then you will be conducting fogging on various cycles and frequencies. After each one, set up your experiment again, test. So you probably do, I'm not sure, probably surface contact swabs, or you might do air sampling for whatever, yeast or molds or something. So whatever it is, whatever the reason you're doing the fogging for, that's your target. And if you pin down the limits that you need to operate to, then you collect your data over a number of cycles, plot the results, and then see what happens. Yeah.
Okay, and Cleo, so you mean rapid Petri films are considered tools for validation?
Yep.
Yeah.
Fair enough. Yep. Yeah.
Okay. Fediyimi, is TBC a sufficient microbiological sanitation validation test?
Total bacterial count. Yeah, I mean, it can be, absolutely. But the only person who can decide whether it is or not is the person who's undertaking the validation, because they're the person who's on the ground. They know why they're doing it. So, for example, I mean, if you're producing a low risk product, for example, shelf stable, dry powdered products, there probably isn't a whole lot going on in terms of risks. You could arguably say TBC could be fine in that case. If you're producing a very high risk product, where you're supplying very high risk sensitive groups in the population, who might be exposed to, say, Clostridium, Salmonella, or something else, then you probably want to get into specific targeting of the pathogens or the hazards at that stage. So it all depends, and you're the best person to assess that on the ground.
Okay, thanks. How do we get the passing criteria for specific industries? How do we determine the passing RLU?
Right. So your HACCP plan should kind of feed into that. If you've done a good thorough HACCP plan, it should tell you, because you will have already gone looking for that information. So where could it be? Well, it could be in legislation. It could be in commodity standards. It could be in microbiological criteria like the European Union defined. So that's particularly focused towards finished product. But it may not exist, so you may need to do your own bit of work on that as well to determine what is acceptable or not acceptable.
Okay. What's the usual number of sampling points for validation?
Again, it depends. It depends on the cleaning procedure. So if you're doing cleaning, say 3 or 4 times a day on a particular, item of equipment, you collect data quite quickly there. If the cleaning procedure is only once a week, it'll take a bit longer. So what we're talking about here is statistical significance. And that can be measured and calculated out using the appropriate tables, etc., etc. I would suggest to people, just in the initial case, don't worry about that too much. Just take enough samples to build up a good distribution curve, and you'll know when you've have a sufficient number of samples, because the curve will look complete and it will look normal.
Okay. Alan, how many documents do you think would be sufficient to include in the validation study?
As many as is needed and as appropriate. Yeah.
Okay, Sergi, if we have 7 buildings, can we consider data from different buildings as one and create a trend and validate, or shall we validate cleaning per building?
If you mean building a separate operational plant, again, it's just different personnel and different products, I'd say you need to do it on a plant basis.
Yeah. They could physically be different as well, couldn't they?
Could be lots of differences. Yeah.
Adaku, how do we get the... Oh, we've done that. Can we include pathogens for validation?
Yep.
We've done that. Yeah.
Definitely. You may be doing it exactly for the purpose of a target pathogen, in fact. Yeah.
Okay. Is there a reference that you know of for food statistics?
Yep, there is. You can use standard models. So what I will do is I'll dig out some references later on and send them over to you, Simon. Yeah.
Yeah, great. Yep. That'd be great. Yep. Okay. Is there a different standard RLU for different equipment or utensils using luminometer and swab sticks?
Yeah, so I suppose the short answer is yes, and it depends on the application. You might be looking for something approaching 0, particularly high sensitive operations, as where you'll have a looser criteria for lower risk. So again, it really depends. And in fact, if you're using those type of kits, you need to do your own correlation and validation, usually against more traditional swabbing and testing methods. So that's a whole other day's discussion, to be honest. But the short answer to the question is yes, you can. Depends.
Okay. Nearly done. Mark, when choosing an allergen test kit, what is a good LOD to use to assure that lines are cleared of any allergen after cleaning?
Again, it all depends. It depends on the allergen. Depends on the available technology. The detection limit of the kits you're using. So you may need something that's very sensitive, or you may be okay with something less sensitive. So there's lots of depends. In there. Yeah. Okay. But just on all those general points, that's where the pre-validation notes in the deck come into play, guys. So there is a bit of prep work, a little bit of work to be done, and you have to do a bit of work. What the tool provides you is, once you've done that spade work, you have a nice, easy tool to get the benefit of that work out, and insightful decision making can then take place. Yeah.
Okay, great. Ericsson, what's the usual sampling size in centimeters squared?
It depends on the test method being used, and refer to the documentation that comes with the test method.
Right. Okay. Matthew said, excellent webinar, useful info, and well explained. So excellent. Where can we find an Excel template for the capability study?
So safefood360.com /resources. If you just go to the Safefood website, you'll see resources on the top of the menu list. Yep.
I will include the direct link in the follow-up email to that page. Okay, I think we've gone 10 minutes over, so we're going to leave it there. Excellent presentation as always, great content, and obviously there's more to it than this with the resources available on the Safefood 360 website. So yeah, fantastic. Thanks very much, George.
Hope you're welcome, Simon. Yep, thanks everybody for taking the time out as well. Yep.
Okay, have a lovely weekend, George.
You too. Take care.
I'll be
Cheers.
in touch.
Okay.
Right, just the certificate that I'll load in the sidebar for you now. That's you download that image, you can print it and sign it yourself, or you can open it in an image editing software such as Microsoft Paint and type your name. We can't, there was 2,500 people registered for this webinar, so I can't personalize them, unfortunately. Okay, thanks for your attendance and for engaging today. The presenter is vital, obviously, but so are you as well, because you asking questions and typing in the chat bar and coming along makes these Food Safety Fridays webinars what they are. So thanks again. We'll be back next week with Tony Connor, and I think we're talking about SQF 9. So hopefully you can attend. Watch out for the emails in your inbox. We'll send you a email after this with the slides, certificate, and the recording with links to Safefood 360. Okay. Happy Friday, everybody. Take care. I'll speak to you next week. Bye.